Hey, Ag Teacher Thoughts here. Going to show you some of the results of our Roman concrete lab. So these are the samples that we worked on. I'll tell you just a little bit about what went on. So the first one I should probably show you is as we were doing it, I realized, gosh, man, you didn't do a control. So how can we know what it's supposed to do if we don't have a control? So I just did this one. This is regular concrete mix. This is the ready mix that we got out of the bag. And the rest of these samples are our student mixes. So they're what we put together with varying amounts of quicklime in them. Did the lab go well? Yeah, yeah, it did. It was actually really, really fun. We had some incredible things going on. We had water mixed, and then we had steam, and we had cups that were getting hot, and we had successes, and then we had some failures. So let's talk a little bit about some of these, and I'll give you some close-ups and kind of tell you where things were going and kind of how it turned out. So let's at first, well, we'll look at the control. So give me just a moment. Okay, so this is our control. Now, one of the things that we were doing is we were using an infrared thermometer to look at this. This is just basically about room temperature here, okay? These other samples have been sitting in here all day. They're about 65 degrees. And let me tell you, there you go. That is not where they were when we began. So, see, we've got some temperatures here. So this is one of our samples. This one here, it looks like its highest temperature was 139 degrees. This one did have a little bit of material left over on the top. Let me look at this one and see, what was it? This was a 20% mix. So this was 20% by weight. Well, we didn't do it by volume, we did it by weight. So it was 20% quicklime, and then it was the other 80% was the ready mix. This one got, again, up to 139, basically 140. Okay. We had another one here. This is another sample. This was also a 20% mix. And these numbers on the side, these are actually the temperatures that it got to. So we'll just put this one like that and see if we can go through some of them. Here, we'll keep it from rolling. So when we started this, we had fairly cool water temperatures when we began. That was about 64 degrees. I think the ready mix at the time was about 68. So right off the bat, we had 99. The next measurement was 129, 142, 148, and then it started dropping down. And that's in degrees Fahrenheit. We did measure one on the bottom of it where it had been sitting on the countertop, so it wasn't radiating heat out, and they got 156 on there. Okay, so the quicklime, remember, is an exothermic reaction, so it produces heat as that chemical reaction occurs. Okay, let's see if we can get another one. I cover up some student names there. Okay. All right, so their water was 58.9 degrees when they started. Their mix was 69.1. Right away, it went to 83, 88, 96, 105, 120, 147, 161.2, then it started going down to 135. Okay, let me look and see if I can find. And this one was a 30% mix. Okay, so if we look at some of these differences here, this one wasn't, it is solid, but there is a lot of loose gravel up top. This one is also solid. It did have some cracking. This one got really hot, but it didn't crack. So there's not really any cracking here. So we're going to have to kind of look at some of the variables and why that changed. But that was a 30% mix. Okay, let's bring this one here. Got the student names covered. There we go. So 72.5. This one was a little bit slower in starting out. And there could have been some variables as far as which batch of quicklime they got. So we're going to try to control those 72, 74, 75, 78. And then it just took a little while for this one to really get going. This one ended up, I think one of our last measurements there was 134.8. Again, this one's solid. And there is some minor cracking in there. You can see that minor cracking. Let's see if I can get the next one up. Okay, cover all those student names. And this one here, this was a 50% mix. These guys wanted to give it a full send on that. So started off with 73, then suddenly 80, 86, 91, 100, 140, 163.8. However, their mix completely dehydrated. Okay, there's zero structural integrity on this one. It basically turned back to sand. You guys can kind of see that I'm just mixing this one around. There's a little bit of it held together. This one may have needed more water to complete the reaction. Okay, so that is some of our Roman concrete. Definitely a lab that I'm going to work to perfect. Really enjoyed this one. The students held their attention on there, seeing the exothermic reaction take off. They were kind of competitive. They wanted to see whose would get the hottest the quickest, or whose would reach the highest temperature. And some of them are disappointed when theirs took a while to really start cooking. And like I mentioned, they got up to 168 degrees. Some of these cups were steaming. Things that I might look for in changes in this lab: don't mix it like regular concrete. The one that fell apart, so this one here, I think the problem with that one is I had him take it just to the right consistency for concrete, and there just wasn't enough water. Some of the ones that were actually fairly successful and formed a solid mass of concrete, they had standing water actually on the top of their mix. They had over-mixed it, or excuse me, over-added water, so it was kind of runny. And it was those runnier mixes that actually performed better. So what we're going to do is we're going to let these go ahead and cure for a couple of weeks before we do any sort of strength testing with them. So we're going to, I've got a drop hammer that we created, a big chunk of bar stock, 1-inch diameter bar stock in a tube, and we just drop it from a certain height. And as long as we repeat that height, every single one of them will get hit the same. So we'll test those probably 2 or 3 weeks. We'll give it a chance to fully cure. I did a little bit more reading, and they're saying, you know, some of that concrete might take weeks or months to get its full strength, or it might need additional water. I don't know. We're going to go through it just like it would be a regular high school lab, which it is, and we're going to give it 2 weeks, and then we're going to wrap this up. So one of the other things that was kind of interesting is right after this lab, I actually met with our building maintenance individual, a gentleman that runs our building maintenance, and he actually came from the concrete industry. So I brought him in here and I showed him what we were doing, telling him about the Roman concrete, how we were adding quicklime to it. And he's looking at me and he's like, man, heat is the enemy of concrete. You really don't want heat in there. You don't want it to get really hot. I'm like, well, you know, this scientific paper I read was saying that heat was a good thing, that it allowed advanced chemistry to take place and it allowed for different formations. So we're taking a look to see what it does. And then he was telling me that there's some other groups that are trying with different forms of lime, just simply because they can't get the clinker right now. They can't get that Portland cement due to shortages. Why we still have shortages, I don't know. But what we're going to do is we're going to keep doing this one. I'm going to refine it a little bit better, develop some worksheets to go through it and some lab handouts for it. But overall, I'd say this is a win for a lab. Those of you ag teachers that are watching this is my Ideas Unlimited, hands off. But no, actually, this is going to require some specialized equipment to make it work, or some of the ingredients are expensive if you buy them already done, or you got to make them yourself, which is actually part of the lab, which is part of the fun. But this was a good one. Definitely a lot of fun. Probably one of the first high schools to ever attempt a Roman concrete lab since that paper came out. And hey, we'll see how it goes. So this is video 2. If you didn't catch the other one, go ahead and watch video 1. And I'm going to go back to cleaning up the lab. I've got a lot of glassware to clean up. Gosh, we played with concrete in a lab. So yeah, we've got some cleanup to get done. But I'll shoot a third video when we get to the testing of the concrete, and we'll see how it goes. So we're going to try to break it, and then after we're done breaking it, we're going to see if we can get it to heal back together. See if it still has that self-healing, or if we need a larger volume to do self-healing. But overall, fantastic lab. Much more enjoyable than slump testing or some of the other things that you can do for a concrete lab. Those of you that watched the other video, I mentioned Pykrete. That's another one of my concrete labs. So I think I'm going to get kind of a little series of concrete labs for a guy that's not really super knowledgeable about concrete. But this was a fun one. All right, so I'm going to get to cleaning, and I'll catch you guys on the next video. Thanks for tuning in. Have a good night.